remember, that is my take on it. Always go back to the NCA website for specific information. That's the most up to date. So let's start by just talking. Level 1 is there to be a foundation level course. So level 2 and 3 go on to specialise, but level 1 is that foundation. So students who leave school with only level 1 have sufficient foundation to live life and do the things they need to do with that. So that's what it's aimed at. So the intent is that we would teach all 4 of the different standards that we have designed. There is also a limit on evidence that the ministry have designed in consultation with the Universal Design for Learning, with experts in NZCR and so on. And the guidance is that for level 1, the amount of evidence that is required, and this is across every single subject, will be around 800 words. So students should be able to do an excellence answer in 800 words. If they were going to do it as a presentation, slides, 6 to 8 slides would be sufficient. Or if they're going to do it as an audio recording or video recording, 5 minutes is the maximum that they would expect it to be. So that gives both students and teachers the limits of what would be expected. Of course, we're not going to penalise kids if they do go over that, but that gives us that guidance of how much evidence is enough. So in terms of teaching and learning, one of the big flexibilities is, one of the big strengths of NCA is that flexibility. And so that's where we're still going to be doing our statistical inquiry cycle. But we're going to, while I will keep using the PPDAC as the cycle, it is not the only statistical investigation cycle worldwide. And so that's why the standard will explicitly just say a statistical inquiry process. However, as I said, I will personally keep using the PPDAC cycle because that's what I'm very familiar with. So the focus in statistics. So level 1, what we want to be able to think about, sorry, I'll just enlarge this a little. We want to be able to think about visually inspecting graphs so that students that leave with level 1 can look at a graph on Twitter, on Instagram, on the newspaper, in an article, wherever, and they can identify visually what they see, the patterns, so that they can form their own kind of assumptions. So the whole idea of fake data, people are critiquing it themselves. So when we're talking about data tells us stories that are supported by evidence, and that's important. That's the statistical stuff. So we want students to be able to look at the data that they have, the variables, the type of variables they've got, and decide what kind of graphs they can draw with that. We want them to be able to look at the features of the graphs they've drawn and look at the graphs that they've drawn and know which features to identify with. Equally, we want them to be aware of their language. So most of the time we don't have population data, so we only ever want to use those suggestive language. So a lot of my algebra kids, for example, we teach them x equals 4. That is the only answer for that particular problem. And so they get used to the idea of this will be that. It proves that. And when we're dealing with statistics, we're not proving because data isn't completely certain. We've got variation. So we want to be aware of the language that students are using. And with that 800-word guideline, we want to make sure that they know how to summarize. So summarizing things in their own words, writing short sentences and paragraphs and getting that information across concisely. So personally, this is what my teaching plan is going to look like. I'm going to start with some introduction to data and investigations, and that talks a little bit about observational studies, experimental, the types of variables, numeric, discrete, etc. And a little bit about how I can collect data. And then following on from that, I will look at covering each of the 4 different investigation styles. Now for the assessment, the students need to select 2 of those, but what they do is they collect data, they draw some graphs, and depending on what graphs that fall out, that will determine what investigation style they have. So therefore they need to learn all 4 styles. So the 4 we've got to look at is our comparison, our relationship, our time series, and our experimental probability. So kids need to be able to look at a graph, say a box plot, and know, oh, this is a comparison investigation, and the features I need to discuss are. Okay. So in terms of my initial idea, just at this moment, this is what I'm thinking. About a week and a half at the start of the year, because the start of the year is always a bit messy anyway. So a week and a half to get some introduction stuff done, and then a week and a half on each of the investigation styles, making sure I cover the features and conclusion for it, and then going on to the assessment at the end of the topic. So I personally I'm planning to have those workbooks updated, ready to go, because that's what I'm going to be using. And however, I have updated recently my year 9 and 10 stuff to be in a similar style as this. So you are welcome to pop in and have a look on those if you're interested. So content, what is the content we cover? So when we first started the group, we looked at what is the significant learning. What is the learning that is too important to be left to chance alone? And so this is what the learning we've identified for this standard. These are the parts that relate to it. So it has to be at curriculum level 6, and so we need to be able to look at our collection of data. We need to explore some data, we need to analyse some features, and notice there I've identified explicitly which features we want to talk about, and then we need to form a conclusion. And these generalisations, which is our conclusions, that was done, there's a little piece of work that Chris Wild had done looking at what does generalisation mean in statistics, and so this is based on the recommendations there. That comparison, a generalization is making an inference. Relationship and time series, you have to process all the information to make a prediction. So that's your generalization. And an experimental probability, it's that long run relative frequency. So note there that if I take, for example, the comparison, which we know as multivariate, but that comparison, we've been doing things like shift, overlap, outliers, etc. as well for the last quite a few years. However, we're trying to, year 11 being foundation, we want to focus on the real core of it, the really, really important stuff, that if kids only have level 1, this is the core that they know. So that's why for comparison, we've just got shape, centre, spread. And at level 2 and 3, we will do more specialisation. So when we initially collect some data, I want kids to be able to, have a data set and run their fingers through the data set. And we do this with some of our year 9s and 10s a lot. And it's drawing some summary graphs and just getting a feel for the data itself. So what I'm going to do now is just go through each of the investigation styles and look at what some of the things that you need to know about in terms of the teaching side. So one of the things that we know is that to make an inference in a comparison situation, coming from the data being from a random sample is very important. So we've had some big discussions, and what we've identified is that at year 12, that's when students go into stratified, simple random, systematic, all the different types of random sampling in great detail. However, at year 11, we want them to understand random versus not random. Or I've got a little picture there that I use, random versus biased. So random means I've got a bunch of lollies where there's a mixture of different types of lollies, different flavours, different lengths, different everything. Whereas a biased sample would be only the jelly beans. And so this is the kind of thinking we want kids to be developed in Year 11, is understanding of random versus not random. So I don't need to explicitly teach random sampling, simple random sampling method, for example, or a cluster. I could if I wanted to, but it's not required. And what we have said is that quasi-random sampling methods are acceptable. So what that means, quasi-random, means things that are close to random. And students need to have thought about this. So part of it depends on the variable that you are investigating. So say I want to know about the hair length of Year 11 students at my school. And if I take my class, I can look around my classroom and go, oh, I've got some boys, I've got some girls, I've got different ethnicities, there's different cultural beliefs that have to do with hair. I've got a mixture in my classroom of kids from our school. That is close enough to a random sample. And so if we can now say that exactly that, this is close enough to being random. However, as I said, depending on the variable we measure, if I was looking at the running speed of students, how long it takes them to run 100 metres, we know that when the schools do timetabling, you can end up with a class with lots of PE students in it, for example. And I would look at that and go, that is not close to random. That has lots of PE students in it. So in that case, I could not do an inference. So when you've got a sample that is clearly biased, you cannot go and form an inference. So later in terms of the assessment, it means you can still get the achieved, but the conclusion that's required for merit, you couldn't get that because it's a clearly biased sample. So that's the understanding we want them to have. Biased versus random. Sample size wise, I know Chris Wild and others talk about a minimum of 20 per group. So my general rule is to use about 30. I plan to collect data of about 30. On the day, I might only get about 25 in this group and 22 in the other group. But my plan is to aim for about 30. More, obviously, is absolutely fine. So in terms of Year 11, as I said before, the key focus is visual inspection. So shape, centre, spread. I want to visually look at the graphs. So when I look for the spread, I want to look at how wide the boxes are. So that's why I've drawn those little red arrows there. And I get kids to just look at the width of that box and compare how wide those boxes are. And if I jump for a second to NZ Grapher, in NZ Grapher, one of the things that it has, if I just select, I've just got a random thing here, there is an option to do, or is it box no whisker down here, and so I can, and in fact there's another option, hide points, so I can just look at the box itself. And if I have my categorical there by sex, I can now just compare where's the centre of those boxes, and it's about there, that middle, and so for forming the conclusion and things like that, as well as that centre and spread, I often quite like this graph to explore it. So that's all I've said there, is just kind of identifying it. Oh, and there was also a shape option that our lovely Jake has just recently added. So if I take that off and I take off the box, there is a shape outline here, which then goes and draws a shape over the top of it. So previously I'd adjusted the point size to make the dots larger, and I found that helped, as well as the stack dots. And when I'm teaching it, I'm going to be teaching first to draw the shape over the top of it like that. And then I will introduce being able to get NZ Grapher to add that shape outline over the top. So there's a couple of thoughts for you. So to form a conclusions, student need to know what the population is to be able to make that inference. And in this assessment, we've said that students identify the sample themselves, but the teacher will tell them what the population is. So that means that when they come to get their assessment marked, because the teacher has given them the population, if the teacher is wrong in what the population is, the kid's not going to get penalised for it because that's what the teacher told them would be the population. Obviously, I'm going to teach them what samples and populations are because they're vitally important. But in terms of that assessment, we're not going to get pedantic. And as I said, we want to visually look. So we're going to use the half three-quarter rule. So we are not using, you do not need to use the overall visual spread versus difference between the mean rule. You are welcome to if you like, but it is acceptable to use the half three-quarter rule. And that can be used with any sample size. And the reasoning for that is because while we know that you may get some false positive negatives with this rule, for our curriculum level, the difference with sample size and connection to sampling variability is not an issue until curriculum level 7, which is year 12. And so the MOE is completely supportive of us using the half three-quarter rule for this, for any sample size. Because what we want is we want a visual rule that kids can look at a graph that they get on any form of media in their lifetime and have a just in their pocket rule that will give them some rough guidance. So that's the reasoning behind. So I do 2 different ways with my kids. I do the shading it in, and I also do median inside outside the box, and then I let the kids choose which one they prefer. But when we've also looked at this, our statistics people were quite happy that the idea of sampling variability is inherent. It's built into the half three-quarter rule. So we no longer need to trot out the sentence, if I took another sample, the data would, the median would, etc. We no longer need that because that sampling variability idea is present within using the rule. So relationships. In a relationship, we want to look for our trend, our direction, and our strength. So we're used to dealing with direction and strength in the current standard. We've also added in the trend, which is looking at whether it's linear or not linear. And part of the reasoning for that is that that's one thing that we do. We don't just put the regression line on the graph. We actually have to look at the data before we do that. Before we decide how to model, we need to look at that data to decide is a linear pattern appropriate or not. And so we don't need to go into detail about, maybe it's an exponential or maybe it's a quadratic, or we don't need to do that. The students just need to be able to say it's linear or it's not linear. So then we get to the conclusion, and this is a bit new. And what we want to do is that because this is our generalization, we need them to understand they're making predictions for their data, for the people they've got information about or the objects they've got information about. And we just want them for focusing on interpolation, so predicting within the data they have. And we want this visual approach. So I'm not going to be just adding a least squares regression line and talking about that. What I've done is I've just drawn a blob around the data, and by hand I've drawn that line through the middle, the trend line, that red trend line, so that I get a feel for it. I'm visually looking at what the data sees, what is the patterns in the data I can see. And then what I'm going to do is I'm just going to choose one value on the x-axis. So I've just gone to 40 centimetres. And I can then read off from my graph that 40 centimetres, the trend line, that's about 40 millimetres is about 150 centimetres tall. And then that arrow that I've drawn shows that I understand my prediction is quite variable, and it could be anywhere between lower and upper values. So I'm not doing a very formal prediction, but I'm looking at what does it mean to predict. And to predict, I need to take into account any pattern as well as the variation that I see in that data. So that's what we're looking for at a merit level when we form a conclusion. Time series. So when we talk about time series, we've got our trend and our seasonality and our variation. And these are currently covered in the charts and data external, if you've ever done that one. Now, seasonality may or may not be present in the data sets the kids get. But they can talk about some kind of trend, and they can talk about whether the variation is constant or not constant. So then that's our analysis, and when we get to our conclusion, we're still doing a prediction for a conclusion, and the idea is still that we want them to visually tell us what's going on. So we want them to have that understanding. And so Anna Ferguson has put some great stuff together, and there's a link there where she's got these graphs, and what happens is that she gets students to trace their finger over the graph. So they get their finger and they're tracing the pattern as they go, and as they go on to where the data stops, they then need to continue that pattern and see what happens. And in the learning part of it, she gets them to click on this button that says show missing data, and it actually displays the actual data behind it so they can see how close did I get with my prediction. But this is the idea behind what we're trying to get kids to do, is we want them to make a prediction based on this visual understanding of the patterns we see in time series. And so they can write a sentence about a prediction afterwards. Experimental probability. So what we want to look at here is we want to look at two types of things. So there are two types of situations we could deal with. We could have the situation where we are trying to find the probability of something we do not know. So doing a water bottle toss, we don't know the probability of that. Whereas if I'm doing a game which rolls dice and they have to add the numbers together, we can work out the theoretical probability as well as collecting some experimental data. And so these are the two scenarios that are acceptable, as we currently do in elements of chance. So this standard is very much that elements of chance idea. So students will need to define what it is that they're wanting to experiment, what a trial is, and they can still manage their sources of variation in this. Again, 30 trials is good. Personally, I'd like to do a little bit more, just so that they, when they do their long run relative frequency graph, they can start seeing it tending towards a value a little more clearly. But yes, 30 or more would be fine. And in terms of analysis, we'll say frequency they can discuss as a feature, relative frequency, and the mode. Those are three features they could discuss. Our long run relative frequency, so this is their conclusion. That's the combining all the knowledge that they've learnt together and saying, okay, well, we did some testing, we did some trials, what have we found, what are we now going to suggest longer term? That if we did more trials, what do we think would happen? And so we would want to see a separate long run relative frequency graph and an estimate for that. So those are the 4 styles. That's the teaching and learning stuff behind it all. Obviously, I haven't dug into the collecting data and stuff as much, but I'm presuming that teachers are a little more comfortable with that. Let's have a little look in terms of the assessment now. And one of the things that we need to think about is we want to make sure that the amount of evidence required for the 1.1 is a similar amount of evidence required for 1.2, the problem solving. And so we thought about, well, what evidence is sufficient? And we went back to, for example, chance and data. Kids could look at a scatter graph, tell me a few features. Look at a box plot, tell me a few features. And that would get them through to achieved in the chance and data external that we currently have. So we use that as a bit of a model for how much evidence is required. So they do not need an entire inquiry cycle for achieved. And I'll show you that one in a bit more detail in a second. In terms of evidence, we want students presenting evidence that they meet the standard. and we don't want this in exam conditions. So open book is absolutely fine. In fact, open book is strongly encouraged. In the real world, if we need to do an investigation, I will go and open my textbook and flick open documents I've looked at before to get some ideas and thoughts and strength and structure and whatnot that I might have used before. We want to test students' ability to apply that knowledge without limiting students who might have short-term memory issues, without learning needs issues, accessibility issues, and etc., etc. We know some kids are very good at exams, others are not. We just want to see what their knowledge is, not test their knowledge in a very specific situation. That's what the externals are for, not the internals. So the Ministry of Education guidelines for all subjects, as I said before, digital presentation, written report, video recording, posters. There's a huge range of things that they could do. We do, though, as normal, need to make sure that the work is authentic. And so as a teacher, I will be monitoring them doing this assessment to make sure that I'm satisfied that their work actually is their own. Conditions of assessment. So this is from the NCA website. Students need to work independently, but the planning and collection can be done in groups, and groups up to 3. So they will be given a general purpose, or if they want to do their own individual investigation on something that's particularly relevant to them, absolutely fine. They have to plan and collect the data. Additional data, so supplementary data, can be provided as long as they have collected their data for at least one investigation style. Teachers, kaiako, we need to give feedback on their plan. We need to check what their plan is. And the collection could be physical, could be from the internet or a website. And as I'll talk a little bit later, collecting data does not include census at school. And I'll talk a little bit more about that in a moment. We can use that as secondary data, as our sourced data. So data collected should be appropriate to the student. It should be about something that they know and are interested in, and should have access to appropriate technology. So there again, I mentioned open book. Students need that choice. And so there's a little example of feedback. If I wanted to measure their height using if the students were going to measure height only using a 30 centimetre ruler, I'm going to give them feedback and go, no, what's a better measuring tool? Or did you remember how are you going to take a random sample? So I can prompt them. I can't tell them how to do it, but I can ask questions to make them come up with a decision. So timelines, however teachers like to do it. This is my initial thought, is that to decide a purpose, make a plan, collect some data, that might take me 2, 3, 4 periods of class time. We've got 50-minute class periods, so that's my thought there. To explore, analyse and form conclusions, may only need 1 period, may need 2. We do not want to restrict students to being able to provide the evidence by limiting the time that they have. And so if a student doesn't finish writing it in that 50 minutes, that's it, they're done. No, they need to present their evidence. We're trying to remove the need for special assessment conditions so that it is a consistent, fair approach across everybody, because we know at the moment there is not equity in who is able to get those conditions and who is not, because it depends on being able to afford the Ed Psychology report. Okay, so here's the rubric that we came up with through the ministry, and this is the one on the website. So, achieved, investigate using an inquiry process. Merit, statistical justification. Excellence, insight. So, collecting data, students need to identify what they're exploring. So I'm going to explore, so if my general purpose was the weather, my specific purpose might be looking at weather in Auckland over summer. Okay, so that's what we're identifying, what we're exploring, and identify what data they're going to gather. So what are my variables going to be? And I'd like to have some units in there too, please, at year 11. And this is where, as a kayako, I'm going to check, have they got appropriate data? Or are they collecting data that's just going to lead them down a rabbit hole and not give them anything useful for their assessment? They need to show, notice that word, they need to show that appropriate data was collected. So they could, I observed them in class, that's sufficient. They present me with the spreadsheet, there is my data being shown. And while they are collecting data, they have managed sources of variation where appropriate. So summary displays and statistics given where relevant. Then describe at least 2 features of the data in context. And so remember this visual display, and we need to do features for 2 styles. So 2 features of a relationship graph, 2 features of a time series graph. So they need at least 4 features, 2 from each, to get to achieved. So that's similar to skill as we do for like the 1.2. Do some calculations. Merit, now I need to do all stages of the inquiry process. So I need a conclusion now. And so I need that in full, and that conclusion, which has to be relevant to the purpose, is in context. So I need a conclusion for both investigations. So if I've done a relationship, I need a prediction. If I've done time series, I need a prediction. I need 2 of those, 1 for each. And of course, I must justify all of my features. For merit, do it properly. So that's your full investigation. Then excellence, we need to have real good contextual insight. So that's what we're looking for, something a bit more than just the merit. And often we're thinking about, if my conclusion is done separately, I need to now draw that together and connect it back to the purpose. That is now starting to weave that context in. I also need some statistical insight. So that's where we look for reflections, and particularly looking for some statistical understanding of quite deep ideas. So I've also put together that just recently as a marking grid. This is mine, not the ministry's, this marking grid, okay? And it's as good as I could get it at the moment from what we know at the moment. This may change before we start. Have they got 2 different investigations? Can't be the same, has to be 2 different ones. And then there's our achieved, make sure that they do those. Merit, complete. Excellence, complete. And then a reminder about what features and conclusions are involved. So that's what I'll hopefully use as it is, but it may need some tweaking. So let's think now about each of those stages. So a purpose. There has to be a single purpose that they come up with. And a purpose is not an investigation question. So we do not need the student saying, I wonder if this group tends to be more than this group for the population. A purpose could be simply as much as saying my general purpose was about the weather. The purpose for my group, we're looking at the weather in Auckland over summer. Okay, I've got a more specific purpose, but it could even just be something as I'm looking at the wind in Auckland. Okay, so as long as it's narrowing down from the more general purpose so that they can figure out what data they need to collect. Okay, so there's an example for you. Processing for teachers. So we thought about this over the last week or so, and this is some ways that teachers could do it. So you could do a whole class brainstorm at the beginning on that general purpose, and then students can get themselves into groups, and each group would then come up with an individual purpose after we've had a specific purpose for their group once they've done a brainstorm as a class. Could be that we get them into groups first, and then within the groups they just do their own brainstorm and figure out what their purpose will be. That could be that we get students individually to do a brainstorm, hand that information to the teacher, and the teacher puts students in groups where they've got a similar purpose, and then they just tweak that to make the purpose common for them both, so they've got the right data that will meet them. Or another thought, and I should say 4, not 3, the class does a brainstorm on the general purpose. Individually or in groups decide what data they would want, and then as a class decide what data are we all going to participate in collecting. So I would expect to see 15 plus variables if you're going to be collecting it as a class. But of course you have to ensure that every student in the class participates in the collecting of data. But that may be a way to make the workload more manageable for teachers if you prefer. But the data then has to give every student enough information to do their own investigation to meet their own purpose. Planning. We intend that students collect one multivariate data set. And so I would want at least one categorical and at least 2 numeric, so that you're going to get at least 2 investigation styles falling out of it. So students can think about how they want to collect their data. Are they going to measure? Are they going to go to a Countdown or a TradeMe website and extract information from that? Are they going to design an experiment and collect data? Are they going to go outside and measure it? There's a huge range they can do. They need to form that plan, and the teacher will be checking those. Okay, Kayako will check the plan, and that may be just in a casual conversation, not necessarily as formal evidence needing to be submitted for your assessment. If I go back to the ministry's rubric, it just says they need to identify what they're exploring and the data they need to gather. Then we need to see that appropriate data was collected. There's nothing in here that specifies they must state their plan. But we are in our conditions that say the Kayako must check their plan, so they need to have a plan. But we just need, as far as we're concerned, we can just have a conversation with them about it. So this is what I'm suggesting, is that what I'll probably do is I will get at achieved, students will need to identify their variable and give me evidence of that. So I would want to see this written down. They need to identify their sample so that I can go on to give them their population. And I need to identify at least one source of variation. And so that will then meet these criteria. Okay, so in terms of sources of variation, we need to think about, well, how do we make that data more consistent? So measuring height, they take their shoes off. The measurements are then more consistent. Collecting data from the web, I'll only go to get car prices from TradeMe because people can list it on multiple car sites. So if I just look at one, I'm not going to get duplication. Random sampling, we could, as I say, remember we can do true sampling, which would be fabulous, but we can also have quasi-random sampling. We want to know that kids identify it's close to random versus not. So for simple random, I might do a list of the cars that I want, list them from 1 to the maximum, say there are 100, and then I just get a random number generator and choose those cars and write down the information from the that TradeMe website on those particular cars. Or I could toss a coin and say, look, tails, I'll include it, heads, I won't. It's including this idea of random, helping us get closer to random. Cluster, so if I'm doing plants and animals, cluster's quite good. So I'd go find out where all my harakeke flax plants are, and I will randomly choose one of those, 1 or 2 or 3 of those plants, and I'll measure all the leaves on that plant. So remember, I need this for my comparison. I don't need it for the other 3 styles. In terms of feedback, here's a few thoughts and ideas of the kinds of feedback that I would be looking to give, saying, what data are you collecting? What are the units that you're going to get? Is your sample size big enough? how you're collecting it, what the equipment is, what's your sample, what source of variation. So just asking them questions, and I'm going to have that conversation. And one of the things I've included on my marking grid is a tick box where I go off and say teacher checked and approved plan, so that I can make sure that I do check every group's plan, so that they are going to collect data that will work for the analysis conclusion. Okay. Yeah, let's pass that. All right, note. Now, this is where the sourcing, the census at school part, but not just census at school, but data that is, for example, on a web page where it's already been processed and it's in a table, and all the students are going to simply copy, paste, copy, paste, copy, paste. They do not have to do any processing or thinking themselves. That does not count as collecting data. So if I'm going to a Trade Me website, I'm taking some of the data off. I've got to think about what units have been used. I'm doing much more processing of that, and certainly going out and collecting in person or writing a questionnaire, I'm collecting that absolutely. That's what we want them to collect. At least some data must be collected. However, if something gets messed up or they only collect enough data for one investigation style, they can source a second graph or data. So here's some ideas. They could go to Census at School, download some data, but it must match their purpose. So if they've collected data on plants and they go to the Census website and they've got data there about students, that's not going to have a common purpose. So that would be two separate and different investigations which will not meet the standard. So it has to be on it has to be on that single purpose. So if I'm collecting data about Trade Me car prices, I could go to Google Trends or Figure NZ or Gapminder and see if there's some information about sales of cars over time and what's happened. So I'm still talking about cars. So that's the important thing, is the context must be the same. If you're not sure, please ask Ministry of Education. And Cami Sawyer is the person at the moment that is our head of learning area. So she would be the person to contact and ask. Population. So this was what I said before. The teachers will give them the population. The students will I'll say to the students, what's your sample? And they'll say, oh, it's cars on Trade Me website. And I'll say, okay, so your population is all cars on the Trade Me website. Now, sometimes we don't need to get too pedantic with the wording like we have done so in the past, but we do need to at times be specific. So if I'm talking about students in my class as the sample, the population would be all students at my school. If I was talking about price of cars, for the price of cars, it does matter what year that car or data was collected. So for that sample, I would want students to say it's the price of cars in 2022. So I don't need to include the year if I'm just talking about the hair length of students, because that's not likely to have changed much. Whereas the price, we know, is very dependent on time, and so that would be particularly relevant. So data, they've got, as I said, they've got to collect it for one, but they can be sourcing data for a second, but we're recommending that you do it one set of data and the graphs just fall out of it, and then it's much easier for them to connect to the purpose and things. Now that's the part where kids stop working on their own. So for drawing the graphs, doing the analysis and coming up with a conclusion, students do that now individually. So they've got to choose from their data, they've got to choose what graphs they want. They've got to add any features, etc. that they want. There's our features that we are accepting, and note for the experimental probability we've got our frequency, relative frequency and mode. And kids should be able to then tell us the story. So that's our weaving together of the context. For merit and excellence, we need that conclusion. So comparison is that inference. Relationship and time series is predictions. And experimental probability is long run relative frequency. At excellence, we need the statistical insight and contextual. So for the contextual insight, that would be looking for students to draw together those conclusions that they did for each investigation style, draw that together and connect it, link it to the purpose. So that's what we're looking for. And reflection, here's a few things, but obviously there are other ways to show statistical insight as well. So I hope that gives you some thoughts and ideas of where our thinking is at the moment, and should things change, I will do an update to the handout and the video as we get closer to 2024 and rolling this out. Thanks for watching.